you know you want to reduce it to a quadratic, this particular one, but you're saying, wow, x is the exponential this time. This is not something I've actually seen too often. Yeah, okay. So what we've got to do is we've got to do some mathematical hijinks and manipulate it a little bit. So I want you to have a look at that in relation to that. You've got 9 to the power of x, and you've got 3 to the power of x. You can kind of ignore the power of x's at the moment. What's the relationship between 9 and 3? So 9 is 3 squared. Convenient. So I could say that 9, not with that bloody pen I couldn't. I could say that 9 to the power of x is equal to 3 to the power of x squared. Would you agree? You happy with that? I'm a math teacher, so you believe me. Trust me, I'm a politician. Okay, so that is the case. Well, what we can do now is we can rewrite this, and it's going to start to look a bit more like a quadratic. So let's go 3 to the power of x squared minus 4 times, and I'll use their notation, 3 to the power of x plus 3 equals 0. Now that's actually starting to look a lot more like a quadratic. It doesn't look exactly like a quadratic at the moment. Remember what we did in this first worked example when we had the x plus 2 in brackets. What did we do? We substituted, didn't we? We used u. Well, just in case you ever look at the textbook that we've actually got, they used k. The variable doesn't matter. You can use u, you can use k, you can use a Greek letter if you're weird, but you could. You could use pictures of kittens. I don't mind. Okay, it doesn't really matter. And you use pictures of kittens. Skulls and crossbones. That's what you use for variables nowadays. Skulls and crossbones and poison dials. Okay. So what we're going to do is I'm going to use k because they did in the book. Okay. So if ever you're looking at it in the book, you can see it. So what we've got is k squared minus 4. Oh, sorry. I should say let k equal 3 to the power of x. I should have said that. Define your variables. If you're going to do this, define your variables when you're doing your working out, because that lets the marker or me know that you have said, okay, k is 3 to the power of x. And now you can do that with all your questions if you want. Sometimes it's fun just to define variables just for the hell of it. It doesn't help you, but it's fun. Well, we don't need to now. The only reason they had a dot was so that you could see it was 4 times 3 to the power of x. So we don't need to now because we've got a k. So it's now 4k. Plus 3 equals 0, and we are back to our fine, feathered and furry friend, the quadratic equation. Yeah, we can whoop, whoop, whoop. Right, once again, you have the quadratic equation that you need to solve, factorise. Cool. So what do we end up with? Plus 3 minus 4. Add together to give you minus 4. Multiply together to give you plus 1. Oh. Minus 6 minus 2, that would give you minus 8. Just remember, if the multiplication gives you a positive, they have to both be negative. If the number there is a negative, then the bigger one, like, they've got to both be negative. So you've got 1 and 3. It is a prime number. So, okay, so what's k equal?
K equals 3 squared.
K. Just k. K equals what? 3 and 1. Okay, so now we've got this thing here. So we now have k equals 3 to the power of x. Therefore, 3 to the power of x equals 3. What would x have to be to make 3 to the power of something be 3? Perfect. So x equals 1. We've also got 3 to the power of x equals 1. Anything to the power of something equals 1. 0. So x equals 0. So you now have your two values of x. X equals 0 and 1. All good with that? That wasn't too bad. It looks different. Bear in mind that you're trying to reduce it to a quadratic. Think about ways you can manipulate it. And substitution is a lovely little process, method of being able to get things down to usable level, quadratics.